Okay, so let's start. Hope everybody had a good lunch and are not feeling very sleepy. So our next speaker is Vangelis Ghiossis from Voxxed Athens. I'm not going to present him. I'm just going to say that he's into digital application payments. So everybody knows that's a very hot topic now that the banks are opening their APIs. So if you're not involved in the digital banking application space, it's a good time to start. So a big applause for Vangelis.
Thank you. Okay, so hello and welcome to this session. This is about testing, testing automation frameworks. So I suppose you're all interested in testing, which means that you're not developers. So I have to ask, are there any developers in the room? Ah, good. So this is for developers. By the way, are there any QA testers in the audience as well? What are you doing in a developers conference? We should have security put you out. No, I'm joking. This is about you guys as well, because I'll explain in a minute. So just a very quick word on what we do, because I'll need to put some context on the live demo we have at the end of the session. So Advantage is a company for the last 15 years. We're doing financial services and banking applications. We're specializing in payments and mainly in digital banking. And we install and roll out these platforms all over the world, not really in Greece. So we have a multi-channel solution, which means that we support all digital channels. This is our technology stack. On the server is a JEE, a Java Enterprise Edition framework. The web channel is a standalone web application, which is a single-page responsive web application supporting all kinds of browsers from desktops to devices. And we also implement mobile banking apps on iOS and Android natively with the native SDKs. So what do developers do every day? So we are producing bugs, we are chasing bugs, we are investigating bugs, and we're resolving bugs. This is what we do. I was reading this interview by the Amazon CTO, and one of the questions was what Amazon developers are doing every day. And he said debugging 90% of the time. So I thought, great news. One of the greatest technology companies in the world, they do face bugs. So bugs are inevitable, and people react in different ways to bugs. For example, QA testers laugh when they find a bug. Developers cry when they are assigned to investigate the bug. And of course, managers are yelling to everybody that this number of bugs are not acceptable for the next release. Of course, many developers usually say this. I don't know if you have seen this commit message, but it works on my machine. So, which brings the whole idea about testing and testing out of the comfort zone of the developer. Of course, something we also face is that when we merge all these patches and features from different development teams into our development branch, suddenly all these nicely tested and developed features, they don't work together, so something breaks each other, which brings up the need for integration testing and regression testing. And of course, bugs do not exist only in source code, but in specifications as well. So we might have user stories, design documents that have bugs, and this is what makes us say that this is not a bug, it's a feature in developers. But bugs also have a great impact. Some are only annoying to the users. There was a bug quite a few years back in the London dispatch ambulance center that cost many lives. There was a bug in this X-ray machine, a floating point bug, that suddenly this machine has started emitting X-rays, and it killed 3 people. There was a decimal point truncation bug in the Vancouver Stock Exchange that created havoc in North America and broke down the stock exchange for a couple of days. And there was a bug in this satellite launch that blew up the satellite and the rocket, costing at least $500 million to ESA. So bugs have a serious impact, especially in digital banking applications where we manage like trillions of euros and US dollars of transactions every year, and bugs are not acceptable. So how do you get away with bugs. In my experience, you just stay in beta forever, which means that you simply admit there are bugs, you ignore them, put them out under the carpet, and that's it. Actually, there is another way. You can tell your managers that we do not have bugs, we have technical debt. It's a nice way to put it. But how you can get rid of bugs and don't get away from it? You call your QA team. And these are specialists that are having a process, and their process is to understand specification, to create test plans, to write up test cases. These test cases have steps that will reproduce some functionality. And of course, after executing the test, developers take over, they resolve the bugs, and they retest. They do this sanity testing or integration testing, whatever, and they put everything back in order in the product release. But developers and QA have different perceptions. Of course, developers are trying to make a feature, and QA people try to break it. So these are contradictory objectives, and this is what we find daily, even in our company. And test automation actually resolves this problem and brings the two teams together. You might have seen this in the past. It's also a perception problem between developers and QA on what a feature is and what an expected outcome is. And they say that testers have the heart of a developer, but in a jar on their desk. But the most important thing about the bug resolution process is it costs a lot of money. It costs a lot of effort. And what this says is that basically the soonest you discover bugs, it costs less to resolve. And the latest you do at the end of the release, then it's almost a disaster. So let me review the testing landscape for a couple of minutes. Of course, we know about black box testing. This is all about testing some functionality of a system, of a module, by providing some input data and measuring if the output is the expected output without caring about inside the internal implementation. It's a very common method of functionality testing, whereas in white box testing, the opposite happens. You have to open up the black box and actually test the internals of some implementation. This is done usually by skilled developers, by programmers, and it's all about testing things like control flows, for example, passing data, parameters to functions, etc. But this is a very tedious process. It costs a lot, again. I think this has been abandoned in the latest years. There are several layers of testing. Of course, unit testing is at the bottom, where we are trying to test small fragments of code, so-called units. Integration testing, when you put all the features you have developed and patches together and try to figure out if one breaks the other and the whole system works. Sanity testing is a very shallow and small test that allows you to make the decision if it's worth to continue testing at all or give it back to the development team. Regression testing is when you have a tested system and suddenly it changes, you test it again and see if those changes have affected the performance. Acceptance testing is by the end users that are trying to do their scenarios and make sure that they can reach their objectives and desired functionality. And there's a whole lot of bunch of non-functional testing, which I'm going to talk about in a minute. So unit testing, again, units are the smallest fragments of testable code. I'm sure many of you are doing this in your practice. So in an object-oriented implementation like Java or Java Enterprise Edition implementation, unit testing is all about testing a class or even a single method or a small fragment of code. And it's important to make sure that you have tools like stubs and you're mocking objects, you're mocking services you're consuming, because one of the major concerns in unit testing is about the spillage, the so-called spillage, that you're trying to test a small unit that actually spills further to some other functionality. For example, you're testing a small unit that connects to a database and does some more functionality and logic there. So this is not a unit, a real unit test. And of course, what we usually do is one famous command in Maven, just skip tests and go home. Now, APIs have become very important in our software, enterprise-grade software landscape now. So API testing is a specific concern now. Now, APIs, you know, they don't have a user interface, so testing them is about testing the messages and the payload of the services. And testing APIs, you need to invoke the APIs with different kinds of input and expect to measure the output. Even edge scenarios that you're trying to break the functionality and the return data. As I said, non-functional testing is very important. It's quite a few things. It's about compliance testing when you test that your system matches the requirements. It's about localization and translation testing, documentation testing even, testing that your collaterals of the product, the user manuals, the design documents are matching the actual implementation. Usability testing means that the application actually usable. It allows the user to experience what we have designed. Security testing is a very important non-functional testing chapter that includes things like static code analysis or dynamic code analysis, vulnerability scanning of application, binary inspections of mobile apps, etc. And of course, UI testing means that I'm not testing functionality, but I'm testing that I don't have any user interface or user experience bugs. So all this really exhausts our resources. We have to, we need some amount of effort to build the software, and then we need twice the amount of effort to test the software with these types of testing and testing levels. So here comes test automation. So what test automation is some special software and tools that allows us to control and execute automated tests and actually test that the outcome of these tests to assert that the outcome of these tests are the expected outcomes. So this is something that comes in repetitively. It happens continuously, possibly integrated with your continuous integration environment, and have a whole lot of tools to test during the nightly builds. And now, what is a test automation framework? A test automation framework is like a whole paradigm. It's an integrated system that sets all the rules for test automation, and it includes tools, guidelines, methodologies, standards, practices, concepts, reporting mechanisms. Of course, you need to get reports after the test automation runs. And one important factor is how to inject test data to your test environments. So it's not something specific. It's something you can build yourself or follow some methodology. Now, what the advantages are is that, of course, when you write testing scripts, you can reuse them for all kinds of use cases. You can extend the test coverage of the system, extend it from the human testing, and this may become low-cost maintenance after you have a very big library of automated tests, and you simply have them automatically being run every night. And of course, the reporting you are getting about test coverage and test results. But there are also some drawbacks here. There is a large startup cost to be involved in test automation frameworks because you have to build your automation test scripts. You have to procure tools. You have to configure those tools and put them together and orchestrate them together to have some decent test automation framework. And afterwards, of course, the effort that test automation requires in the whole process of software development, it puts some overhead right there. But hopefully, you enjoy some less effort when you're doing all these kinds of testing, human testing, and regression testing, integration testing. And of course, the tools, some commercial platforms come at a price. Now, there are different test automation framework types. I won't go into any detail in each one. Just to mention a few, module-based testing it comes very natural in object-oriented environments like Java, Enterprise Edition. And it's all about modularizing your test scripts in order to orchestrate them afterwards in several different use cases and reuse the testing code. And similarly, the library architecture It sort of tries to consolidate all the testing functions into libraries, again, for usability. Data-driven testing frameworks are those that the actual test data, they drive the orchestration and the execution path of the tests. Similar frameworks, they try to map the test data with keywords, and then you're using keywords to orchestrate the test scenario. There are hybrid frameworks that use all of the above. And there are the so-called behavior-driven development frameworks, which is the one we chose as a company. Now, according to Gartner, all these are test automation framework platforms. These are commercial vendors. The leaders are Hewlett-Packard and IBM, I guess, and some nice newcomers like Automation Anywhere and Progress. Now, the process we followed in our company to devise and invent our own test automation framework was something like this. We have a very large library of literally thousands of test scenarios. We have a repository. We have a team of 20 QA testers that continuously follow these scenarios, and there are tests across all the platforms and the clients and the technologies we have. So we put together a cross-discipline team from analysts, QA, developers, architects, etc., and try to investigate what the tools are, what the frameworks are, and we sort of investigated our human test scenarios and try to see if they can be automated. So you have to determine if these tests can indeed be automated or not. So the next step is to create your automated scripts and choose some orchestration tool to have them being executed. And afterwards, you just keep running the process. You keep improving and maintaining your test scripts. And basically, you end up with a repository of automated test scripts. And we're sort of in the first steps of this process right now. So as I said, in our case, we have a platform, and we have web clients and mobile apps using the same API and business logic. And all of them are being tested with the same business test scenarios. So we thought we should have the same test scenarios being targeting different platforms. For example, the web, iOS, Android, our API, our JVMs, database, etc. And then we thought that we should have scripts in each different technology that map with the steps of these scenarios and use the appropriate tool to automate the testing. So this is the basic concept of the framework. Write the scenarios once, execute in different platforms automatically. Now, as a tool, we're using a Jira plugin. It's named Kanoa. It's a nice tool that lets you organize your test plans. You can create namespaces of test cases. Now, all the test plans have test cases, and each test case has several steps that the tester has to follow. And all these steps are written in natural language, of course. Right? They are addressed to the QA tester that is following the script, and they're trying to reproduce the scenario. And it lets you keep track of the bugs, the execution cycles, etc., how many bugs are resolved. It's linked with Jira's issue bug tracking system. There are so many tools to use for test automation in various technologies and disciplines. For example, I'm sure you know JUnit in Java by now, and Android. iOS has its own suite for unit testing. One famous framework is Protractor JS, used for AngularJS applications. Appium IO is famous for testing mobile apps. SOAP UI for mocking services and testing APIs. And of course, Selenium and Capybara, which are famous web drivers for testing web applications. So there's a whole lot to choose, even more than I have on this slide. Now, there's this concept named behavior-driven development. Anyone using BDD at all? Good for you. So there's also this other notion of test-driven development, which means that you write tests first, and then you implement the functionality until it stops breaking. So this is the same as test-driven development, but it's all about behaviors and features that you describe and you're trying this first, and then you keep implementing until it works. And this tries to resolve the problems of communicating with the analysts, the end customers, and misunderstandings in requirements, and of course all the problems that bugs have, as I mentioned earlier. So BDD is about the process of having, for example, an agile cross-discipline team of developers, QA, and business analysts and users maybe in the team. So they're trying to describe and write down simply what the features are, what the expected functionality is, and they provide examples of this functionality. The next step is to use some test automation framework in order to run these examples as automated acceptance tests, which, of course, in the beginning, again, they fail. And as the team starts to implement and test the functionality, these suddenly work. So you have some progress review of what's implemented and what is working of the implemented functionality and what it's not implemented or not working at all. And suddenly, at the end of the process, you have a very nice documentation, which is, I think, invaluable in what we do in software, that in a single documentation stack, it combines the specification and the tests of your software. So these are the goals of BDD. Now, we have chosen this nice new little tool named Cucumberio. Cucumberio is a relatively new project. It's MIT licensed. It's becoming quite famous right now. It's been downloaded like tens of millions of times. They're even launching now the Cucumberio Pro version with new features. So what this does is a software tool that allows you to automatically test your software, and it runs the acceptance tests of features and behavior. So it sort of injects BDD as a paradigm within the test automation and software development process. And the most important fact is that everyone understands the specification because it's written in business terms in natural language. And Cucumber now has several implementations in all famous technology stacks like Java, .NET, C++, Ruby, and supports all these frameworks like Ruby on Rails and Serenity. And even more are coming up. Now, Gherkin is the language Cucumber is using. Actually, it's a language parser. It's a natural language parser that is using keywords in order to describe features, feature examples and scenarios, and their steps. So these are written in Gherkin. The features are written in Gherkin by the business people or the QA team. And it has some specific syntax in order to bring in the behavior-driven development concept and paradigm. The syntax is very simple, like YAML, for example. It's line-oriented, so the end of line is the end of the statement. It has some keywords, and it uses indentation with spaces in order to have some context and blocks. So how it works again, you describe a behavior in natural language. Supports only English at the moment, I'm afraid. You write the step definitions. You run it automatically, and it fails. Then you write the code to implement the feature or the scenario. And at the end, you run it again, and when it passes, you get a nice report of what happened. So the business-facing part is about writing the business specification in natural language. The technology-facing part is about mapping the actual steps written in English with scripts in any language Cucumber supports. So one basic structure in Cucumber is the feature file. The feature file is a text file that is put in a specific path when you configure Cucumber, and it describes the scenario. And each line becomes a step definition in some language. For example, here in Ruby, using regular expressions, etc. We'll see some examples. But the basics of the Gherkin syntax, the basic keywords are the keyword feature. So a feature, when a line starts with feature keyword, it's about describing the feature we're implementing. The scenario keyword describes an example of this behavior, the business rule. The given keyword is used to tell the system that it's ready to start testing. You can prepare data. You can launch URLs and websites and make sure that everything renders until you start testing. You can combine different sentences with the keywords and but, so it sounds even more natural in English. The when keyword is defining the when steps, which are usually all about events, about actions, either actions of a user, that a user clicked someplace, or events from the system or other systems. The then keyword is the beginning of this step, is about expressing what the expected outcome is. So your test automation script is right there at the point where you do the assertion, where we assert that the outcome is the expected outcome. There are some combinations. For example, there is a scenario outline keyword and with examples, which lets you write a scenario, and instead of writing many feature files, you write it once, and you are reusing this kind of data here as if it was in a loop. So you define it once. So an example feature file. There is an annotation at the top. This is about tagging. It allows you, tagging in Cucumber allows you to group features together, and you can ask Cucumber to orchestrate tests of a specific tag or the whole bunch of your repository. So for example, this feature is about a visitor in the Voxxed website. The visitor needs to read some speaker's profile. So given that I visit the Voxxed Athens website, meaning that I enter the URL and the site comes back and renders, then I navigate to the speaker's page. I look for the speaker named Sam. So basically, this should be a link in the web page. Then I click on its profile and review it, read it. So as simple as that, you write in plain English some use case, some feature, some test scenario. So the next step is to create some steps definition source code here. There are various ways to do this. We'll show you a live demo how we did it. So basically, you see that Cucumber gives you an annotation for every single gherkin keyword, and right beside it is the mapping of the actual natural language step with some regular expressions for passing parameters. As I said earlier, given that I go to Voxxed Athens website, which instructs here a Selenium Webdriver to visit this page with a URL. And then I look for the speaker named regular expression, and this is where the data of the feature file I showed you earlier is being passed to the script. And then the WebDriver is trying to find this particular element and click on it. Is this clear how it works? Is this good how it works? Yeah. Okay, so Selenium, I'm sure you know Selenium is a nice tool for and a framework for testing web application. It gives you an IDE as a Mozilla plugin. We don't recommend that you use the Selenium IDE because the produced code is not easily maintainable. Just go for the WebDriver API. And it basically allows you to run tests in different types of browsers. In our company, we're using this tool, Selenium Grid. This is a server-based installation because we want to run these scenarios unattended overnight, right? So we have a hub that orchestrates several nodes in different operating systems with different browsers. So we run the same test in different nodes in Linux, Windows, Mac OS for Safari, Chrome, and Internet Explorer, okay? Excuse me. Now, Appium is, again, a WebDriver-like implementation for testing mobile apps. It can do that with mobile apps emulators or the real device. So the concept here is to create a device farm, because what we're doing is we're testing different versions of the operating system on different devices from different manufacturers, because some functionality is breaking in those cases. So Appium is driving the whole farm of the devices. One important fact is about how do you inject data in your test automation. You can have files like CSV files, JSON files, database, etc. We thought of a simple solution because what happens is that data, as we test, get exhausted. For example, in internet banking, we have a bank account with $1 billion. We keep account and we're testing payments, transfers, etc., and suddenly the balance is 0. So we have to go back and rewind our test data. So the basic concept of a database container is that we have prepared our best test data, and we run the scenarios, and at any time we can spin a new instance of the same container and go back from the beginning every night. So putting it all together in a DevOps ecosystem is, for example, you can have your CI, your favorite CI tool. You can use your build mechanism like Grunt for building web apps, Maven for building Java apps, and Gradle for building Android apps. And it's accessing your GitLab. This is happening overnight. Developers are at home, and it's a scheduled job. All the commits of the day are in there, and we simply get the latest version of the code. We build it. We put the binaries in an artifacts repository like Nexus, and then we use Vagrant images to spin a new test automation virtual machine that, through Ansible configuration management, is configuring Docker machine to have Docker containers of our application server instances, which are usually a Wildfly application service and PostgreSQL that has been updated through Liquid-based scripts with a new version. Then unit test runs. Then we're using Cucumber and Selenium Webdriver to drive through Selenium Grid all the nodes that are testing across the browsers, and then Appium to test on the devices. We're doing our static code analysis through SonarQube and find bugs, find security bugs. We're doing our performance testing through JMeter. We're doing our security vulnerability scanning through Iconetics. And all these tools, at the end of the process, they update Jira with all the issues that have been tested successfully, and then let the team know that everything went okay in Slack. Okay? So let's see some demo of the implementation. Sam?
Hello, everyone. I'm Sam Shemirani, I'm a software engineer at Advantage, and I'm going to show you some demo if we have time, basically, because we're running out of time. Okay, we don't see anything. Very nice. So I'm going to start with our e-banking. Actually, we have a scenario here. I wanted to show you actually first the manual, for example, behavior testing, that what the user does when it goes to our e-banking to transfer some money. I should put, oh, 1 second. The Wi-Fi? No. Okay. Let me set this up so maybe the IP has changed, because we are using Wildfly actually in development. Postgres as a database server, and Java EE for our backend, AngularJS for our frontend. Here is the IP. Okay. Out of time, but okay, the application was down. Okay, so here is our application. You can use this behavior-driven development. Actually, it's an extension, as Vangelis mentioned, of test-driven development, and we all have actually tried at least once to do some test-driven development, but actually most of us actually have failed because we don't know where to start the development, we don't know what to test, okay, where is the state that I have to start, and there are many other issues in there. So there's a new extension of that which is called behavior-driven development. which tries to solve these problems. Okay. So here is our e-banking, if you can see. Oh my God. What happened? It was working like 2 minutes ago, but anyway, I will show you some code first. So after that, I will fix this and show you. So here is actually a Cucumber scenario, which it basically starts with the feature. It says, for example, what is about this feature file, what we want actually, the meaning of the functionality. You can have some description under it. Can you see that? So it says the user, after navigation to the e-banking, must see the login page and insert their credentials in order to sign in to the e-banking. The user must see the dashboard and navigate to the payment and transfer. Select the own account transfer and see their from account to account, and insert some money, the amount, some comments, and press the submit button in order to do the transfer. After the feature file, you can, for example, put any kind of description that you need to give to developers so they know what all this feature is all about. You can add some rules. For example, customer must have an account in e-banking. Customer should have more than one account. Customer must have available balance in order to make the transfer. And then it goes to the scenario section. So in the scenario, you just explain the functionality in agile framework role, for example, where you say, for example, I as a customer, when I go to the website, I need to do this, do that. So we write this like, as an e-banking user, I must be able to successfully transfer money between my accounts and verify that the transaction has been completed and the money is successfully transferred. After the scenario, actually, the steps come in. Usually, you should actually start with given. You can actually start with whatever you want, but the best practice is start with given. So you say that given that I have an active account in the e-banking, for example, with the customer ID, for example, 10,001. And then you say, when I go to the e-banking website, I see the login page. I enter the username, Logan something. I enter password. I enter the OTP, which is the one-time password for you insert your password once and then it's expired for security reason. And then I must see the dashboard in the e-banking. So I click on payment transfer menu. I click on own account transfer in order to transfer some money between my accounts. I select the from account with the number, some number, and select the to account that I want to transfer the money with that number. And then I insert 100 euros in the text field. I set the transfer date. I insert some comments because it's required. And then I press the submit button and so on and so forth. So you can see that it's actually a lot easier to start the development from the testing, because you know exactly what is your first state and where you have to go, what you have to implement. So imagine that someone gives you this, for example, in the requirement of the software in bulletins, for example, having 100 of bullets. So sometimes you even get bored and you don't read all of it. You read some of it, and at the end you haven't actually developed all the requirements. So actually, in this manner is a lot easier to start the testing, and it's actually more fun, because test-driven development is you're like, okay, today I'm going to do some test-driven development. So you start to write your test, you write the first method, oh, I don't have time, so let me do the actual implementation first, and then I do the testing at the end of the day. So the day is passed, you're actually, okay, you finished the implementation, and you're like, okay, I don't have time, maybe tomorrow, and that never happens. So you don't have the test. In this way, so it's actually a lot easier to do that. Okay, we have 5 more minutes, so let me see that if we can run this to show you actually an automation of the whole process. start?
Voxxed
The workspace. All right. So until this our application is run, I'm going to show you the example of workspace that Vangelis showed you before. Okay. So here is a Cucumber plugin working with, actually we have a Spring Boot application in here, so we can use, for example, the repositories, the dependency injections for our testing automation. So Cucumber has different, for example, it supports all of the, most of the well-known testing frameworks such as JUnit test and as Vangelis pointed out. And you add some options here. So you say, for example, where are the feature files? You write all the gherkin that I showed you before for the transfer. You write them in feature files, and then you say where the test should look for these files. And then you have classes that you have your steps in it. The steps, for example, like this. And then each of the steps are mapped to a method through the annotations that the Cucumber gives you. For example, I go to Voxxed Athens website, okay, open up the WebDriver, the URL, take some screenshots. Actually, the WebDriver has a very nice feature that you can make screenshots in your tests. So let me run this because we are out of time. So you can see that it's come up. It goes actually automatically to the site, the URL that you've given it. Scrolls down to this, clicks actually over the speaker's button, and then looks for my profile. It goes into the profile and then finishes the test. And at the end, actually, you can have a very nice reporting tool that will show you, for example, the steps that you have. Can you see anything? No. Okay. So it has your steps and with the status, and of course the screenshot of the web page that you were testing against. Well, Cucumber has different reporting plugins. You can use actually third-party plugins. For example, we use Extend Reports in here. Extend Reports actually is a very nice reporting tool. You can integrate it with JUnits, Cucumber, and many other testing frameworks. That at the end it gives you a web UI that you can see your test results out of the application. So, for example, the QA team can directly see the test and what's going on and how they go. Well, actually, we don't have any more time. Let me see. Okay. All right.
Okay.
I believe that we're going to accept only one question because we're running a little bit late, but you can find both guys because I assume that you have a lot of questions. I will have. So we're going to accept only one question, or if you're quick, maybe two. So.
Hi. Hi. I want to make a question. Why do you use Cucumber? Why have you chosen Cucumber and not another framework, such as a robot framework, which has the fame to be a little bit easier to handle?
Yes, good question. There are quite a few choices out there. We thought that this was a nice project. It was easy for everyone in the team to understand and implement, including the analysts, the QA people, and the developers. So we had proof of concepts in 2 or 3 days using Cucumber.io. It's a shame about the demo, but you can join us at our stand, and we can showcase the demo both for web and Android apps later on. Okay?
Thank you very much.
Thank you.
I'm not going to accept any more questions because we're running late and people are waiting to come in. But you can find the guys in the Advantage FSE booth. Thank you again very much, guys.